Hi everyone. Today I'm going to introduce two rejected papers from Open Review, and more importantly, I want to discuss why they were probably rejected. I think this is useful because a rejected paper is not necessarily a bad paper. Sometimes the idea is interesting, sometimes the results look strong, but reviewers are still not fully convinced. In both papers today, we can see that gap very clearly. The papers are ambitious and practical, but they seem to fall short on novelty, evaluation, or clarity. The first paper is like 3D object manipulation in a single image using generative models. And the second one is mammal fish agent, memory augmented multimodal large language model agent for pushing URL detection. These two papers are very different in topic, but interestingly, the reasons they were likely rejected are actually quite similar. Both papers try to combine many existing techniques into one larger system. Both papers also claim strong practical results, but in both cases, reviewers seem to have asked the same question. Is this really a new research contribution, or is it merely a strong engineering integration? Okay, let's see the paper one, the OMG3D. Okay. Um, The goal of this paper is very intuitive. The authors want to take a single two-dimension image, reconstruct the objective in 3D, manipulate it in 3D space, and then render it back into realistic images or videos. In simple words, they want to support both static editing and dynamic animation in one unified framework. The paper says that previous methods usually do one of these well, but not both together. So their idea is convert the object into 3D, refine its texture, estimate lighting, manipulate the object, and then render the final result. And you can see this picture. The pipeline has two named modules. One is Custom Refiner, which which improves textural quality using a customized diffusion model, DDIM inversion, depth control, and feature injection. The other is Illumi Combiner, which adjusts the estimated lighting so that the object matches the background more naturally. So the authors are not just changing the object itself, they're also trying to fix texture realism and scene lighting, which are usually hard problems in image editing and animation. To be fair, this paper does have strengths. First, the task is attractive. It is easy to understand why users would want this. Second, the pipeline is practical. It uses 3D as a bridge between editing and motion, which is a reasonable design choice. Third, the quantitative examples are visually appealing. The paper reports improvements in both image editing and animation settings. The authors also compare against several baselines and use GPT-4o plus human studies for evaluation. But now, let's move to the more important part. Why was it probably rejected? The first and biggest reason is limited technical novelty. The point is not just my guess. One open review reviews a snippet explicitly says the weakness is a lack of technical novelty and that most of the presented techniques already exist. The open review author response snippets also show that the authors had to add explanations about their core technical novelty, which suggests that reviewers were not convinced that the new contribution was sufficiently clear or strong. And when we look at the paper itself, That concern makes sense. The framework combines many familiar components. SAM for segmentation, image to 3D reconstruction, Dream Boost LoRa, DDIM inversion, depth control net, feature injection inspired by PNP, lighting estimation methods like diffusion light, and even external tools such as Blender, Mixamo, and Adobe Firefly. The paper itself describes its main contribution as a unified and extensible framework where advanced techniques are adapted, redesigned, and integrated. That wording sounds useful, but it also sounds like a system integration more than a fundamentally new method. For a top conference like ICLEAR, that can be a problem. The second likely reason is evaluation weakness. The paper says that the traditional automatic metrics are limited, so it used GPT-4o and user study. That is understandable because realism and visual quality are hard to measure. But from a reviewer's perspective, this can still feel subjective. GPT-4o is not a standard vision benchmark, and user studies can be sensitive to design choices such as sample size, prompt wording, and which examples are shown. So even if the results look good, reviewers may not feel that the evidence is rigorous enough. A third reason is that the system feels too engineering heavy and not fully automatic. For example, after reconstruction, user may manually construct a skeleton in Blender or attach animation like this here. The paper also uses Maximo for rigging and Adobe Firefly to background in painting. Once a system depends on this many moving parts and third-party tools, reviewers may start asking, what exactly is the core scientific contribution here? Is the paper proposing a new learning principle or just assembling a production pipeline that happens to work well on examples? The fourth issue is robustness and generalization. In the appendix, the paper openly admits several limitations: poor mesh quality in complex cases, inaccurate lighting estimation, and difficulty with complex textures. Like in the appendix part, limitations here. The failures cases show incorrect mesh, incorrect color, and incorrect light. This matters because a paper can look impressive when it shows only successful cases, but reviewers also care about whether the method is stable across hard inputs. These failures cases weaken the claim that the method is broadly reliable. A fifth issue is simply presentation clarity. The open review response snippets show that reviewers ask for clearer descriptions of the lighting process and plane creation. Where reviewers already have novelty concerns, weak writing makes the problem worse. If the method is complicated and explanation is not very sharp, reviewers may decide that the contribution is not mature enough. Also, the paper received at least one visible reading of three, reject not good enough, which suggests that the overall reception was not strong. So my overall takeaway for OMG's 3D is this. The paper is interesting and visually impressive, but reviewers probably saw it as a strong engineering pipeline built from many existing components with evaluation that was not strong enough to prove a conference level research contribution. And let's move to the paper two, Memo Fish Agent. This paper is in cybersecurity. The task is phishing URL detection. Traditional methods often rely on rules, blocklists, and handcrafted features. The authors argue that these methods are too rigid, so they propose a multi-model large language model agent that can dynamically use five tools: crawling page content, inspecting screenshot, checking individual images, extracting target links, and searching the web. On top of that, the system has an episodic memory module that stores past reasoning trajectories and final judgment, so future cases can reuse similar past cases. This paper also has a clear strength. The problem is important and realistic. The system is well motivated. The paper includes ablation, sensitivity test, memory analysis, and adversarial prompts, inject experiments. It also reports strong performance on three datasets, especially on author's own Scorefish dataset. So again, the actual question is, if the results are strong, why was it likely rejected? The first likely reason is novelty. Even though the paper calls itself the first memory augmented multimodal LLM agent for phishing detection, and the core ingredient of all familiar: React style reasoning, tool use, episodic memory, retrieval with similarity search, majority voting, and standard agent orchestrating. So the contribution may feel more like applying known agent idea to a new domain than inventing a fundamentally new method. That can still be valuable, but top tier reviewers often ask for more than a careful application paper. The second likely reason is baseline fairness and comparison quality. This is again not only my own inference. Open review author response snippets explicitly say that a reviewer thought the baseline selection was limited and suggested adding reference-based system. Another open review snippet shows the author responding to a claim that fish agent outperformed mammal fish agent on TR-OP. So clearly, reviewers were not fully satisfied with the comparison story. In security papers, that is serious issue. If your baseline are incomplete, or if a strong competing method is missing, then even good numbers may not be convincing. The third likely reason is reproducibility and realism concerns. The authors introduced a new dataset called Skullfish and say it was collected from 5 social media platforms over 6 months. But they also state that some additional details of the collection process cannot be disclosed due to the business considerations. From a reviewer's perspective, this is uncomfortable. If the most realistic data set in the paper is not fully reproducible, then it becomes harder to verify the claims. And because the system used memory from past episodes, reviewers may also worry about whether the performance depends partly on datasets overlap or temporal effects rather than pure generalization. Okay, to conclude, I think these two papers teach the same lesson from two different directions. OMG3D is probably rejected because it is visually attractive but practical useful. But reviewers likely felt that the novelty was weak and evaluation was too subjective, and the system depends too much on integrating existing tools. The Memofish agent is probably rejected because it solves an important real-world problem and reports strong results, but reviewers likely wanted stronger evidence that the method was truly new, fairly compared, reproducible, and robust enough for a security setting. So the broader message is a paper can be useful, interesting, and even impressive, but still be rejected if reviewers are not convinced about novelty, rigor, fairness of evaluation, or clarity of presentation. In other words, good demos are not enough. Top conferences want a clear scientific contribution and solid evidence. And I think that is exactly what happened with these two papers. Okay, thank you.